Hello. For this video, I'm going to fix a mistake I made last time and in the kanji code generation. And after we're done with that, we're going to actually assign the kanji to easier to type keys according to how commonly they are used. And so, in other words, we're making the kanji generation, the kanji code more ergonomic rather than just picking arbitrary characters, which we did last time. So the problem that I wanted to fix was right here. We checked to see if we set the first key in the code we're generating by converting it from an index from a from a ASCII value to a key positional index. And then we check to see if it was successfully converted down here by comparing it to -1. But before we do that, we modulo it with kanji key count. And I looked up earlier and I saw that if we so oh, never mind. I made a mistake here. So we're modulating it by a negative number by a positive number. It's going to turn out negative. So I guess that is fine. What I'm reading is a Stack Overflow question here. So C99 requires that A/B will if you do A modulo B, then this formula should be satisfied if A/B is representable. And so the conclusion here is that if you take a negative modulo positive, it will end up being negative. So at the same time, I feel like separating this is kind of confusing. And if I need to look at Stack Overflow to make sure I didn't make a mistake, maybe it's a little too the code is a little too obtuse. So what I'll do is before I check with modulo, before I modulo the value, I'll check the value to make sure that it did not return an error here. Because really, we should not be doing anything to it if we get an error back. So let's do that, and I'm going to amend the last change. Okay, so now we're going to assign common kanji to easy to type keys. So if we run new sorts make map and page that, let's go down to the kanji section. So the first key is assigned according to a kind of formula which we can't change, which is the radical stroke count sorting order of the key. So everything that starts with has a code that starts with 1 is going to fall under a certain range in that sort order, and we can't just change the sort order however we want. It's kind of chosen for us by the language, by the Japanese language. So what we can change though is the second key in the code. The reason being because we're going to have a system whereby we type one character, and after we do that, it will show the possible choices that you have after that. In this input system, I type 2 characters because this uses 3 character codes. But in our system, we'll just type 1 character, and we'll have a kind of display like this down here. And it might just look the same as this display right now. And then that way the user doesn't need to memorize what the second key is. The user can look it up just as they need to by typing the first key in and looking at what appears down here. So the first character is set in stone. The second character currently it assigns 1 to the most common character in the range, and it assigns it assigns 2 for the second most common character, And then if we go all the way down, it assigns slash to the least common character. And so you can see that it is essentially just assigning keys and kanji to in like a descending rank, where one is the most common, then two, three, four, five, six, seven, eight, nine, zero. Those so the most common kanji will be in that row, and this is not really what we want because that row is kind of hard to type. And then the next most common kanji will be assigned to the keys Q, W, E, R, T, Y, U, I, O, P in that order, and so on until you get to the end of the last row. And so what we want to do is we want to, before we start assigning keys, card to key index like this. Is that the right place? No, but as we're so what we do is we loop through the free kanji codes, and we assign kanji to them. So what we want to do is we actually want to sort these free kanji codes, and we will sort them according to what is the easiest to the whatever according to what row they're on. For now, we're just going to sort it according to what row they're on, and maybe according to what hand you type it with. So we'll prefer one hand over the other, or we'll prefer alternating hands rather as we type in the codes. And so that's how we're going to do it. And I suppose we're ready at this point. Is there anything else we need to think about? Well, maybe we'll specify exactly what the sort order is going to be. So I'll write it over here in this file, and we'll say first. So let's say first sort by which hand. Prefer alternating hands. Alternating hands. Okay. So sort by. Let me make this prettier. Sort by first which hand. We also want to sort first by the first character, because we don't want to mix up the first key. So we're going to sort this entire array, and we don't want to mix up what the first character. We don't want to mix up codes that have this different first characters. We want to make all the codes that start with a single character be contiguous in the array. So first we sort by the first character in the code. Then the rest of the sorting goes by the second character. And first we'll sort by preferring preferring alternate hands. Then we'll sort by row, and then we'll sort by column. And I guess we'll say that the column that is J is the best. That's like UJM is the easiest column to type, or RFV, right? This is the easiest column, and I can put the numbers here too, just for completeness sake. And then, so let's call this A. Then the next column will be 3 EDC. Now I'm regretting using capital letters. I guess I'll keep doing it. EDC and 8 IK comma, and C is we'll say this is 2 WSX and 9 OL dot, and then the second to last row is going to be the pinky. It is 1 QAZ and 0P semicolon slash, and the very last row is the one that you have to reach your index finger with. Move your index finger to reach it, which is 5TGB and 6yhn. Okay, and now if we calculate how many characters we've typed, it is 5 times 2 times 4, which is 40, which is what we expect. Okay, so this is kind of imperfect because we're doing some strange things, like we're preferring 0 instead of, we're preferring 0 over, say, h, and I think h is probably easier to type. Well, actually, no, because we're sorting by the row first. So this basically means we're going to prefer semicolon over h, semicolon over h, and that's probably fine. In any case, this is still not really super ergonomic. It's better than what we have before, right? But it's still not great. Let me fix this. There, capital. So because we're not like taking into account, like, did we if we're using the same, this might work for if we're alternating hands, this thing, but if we're not alternating hands, if we're using the same hand, we actually want to prefer the current row, right? We don't want to. So under this system, what I've just described, 5f is considered easier to type than 5-1. But actually 5-1, if you think about it, should be much easier because you are you're actually changing 5-1. 5f requires you to use your index finger for like 2 different keys, and requires your index finger to move quite a lot. So for now though, I think this is actually not going to be too bad. So let's we also don't want to break the current test, so we're going to just kind of keep the current method. So let's see here. What we want to do is add a flag which turns on this alternate sort order. And I think that we don't even check for, oops, wrong file. We don't even check for too many arguments in make map, if I just saw that right. Make map A, yeah. We allow the user to type extra junk after the arguments. So what we'll do, I think, is we'll have a int ergonomic sort, right? And we're going to turn that on if the user passes a certain flag. Right. So we'll say ergonomic sort 0. And let me look at how I've done flag parsing in the past, and I'll just use the same method here. So let's see. I loop through the arguments. I see. Well, I loop as long as we still have arguments left, and then we drop the first argument. We kind of pop it off, and then we check for each different allowed argument. So let's just do that. Let's copy this, and we will change it as we need it. And this is kind of a bad code because like it doesn't recognize, say, 2 single character flags combined, which I think most Unix users would expect. So I'm not. Yeah, we'll fix it eventually if the demand arises. So we'll say, what do we call this flag? Maybe S. We'll just call it S for sorting. And this means we're going to say ergonomic sort equals 1. Okay. Otherwise, we I guess we still want this thing. No. We don't, because there are no like optional arguments, or there are no positional arguments for this command. So we don't want that. And okay, return 3. Yeah, let's try that. New sort, make map, and pass a flag. Why did not that give me an error? Not. Should be printing. What did I do wrong? So argc is greater than 0. Excuse me. Oh, because it's going to stop as soon as we don't hit a flag here. So if we did -ASDF, it would show an error. Okay. So I guess what we actually want to do is we want to always loop over the arguments. Or, yeah, let's just do it like that for now. So I make map. Let's make, oops, make sort make map ASDF and ASDF. Okay. Now let's also have a test for that. I don't want to screw it up later. So called start test file. Let's say bad flag. We'll call it make map. I think I have to declare it separately. So we'll do char const argv is where do I want the dots? Yeah, so we dereference it and it should be const. We dereference it again and it should be const. Okay. Dash, what's a bogus flag like -1? Okay. Okay, make map argv2. Then end test. And we expect, we also want to print out the error. Excuse me. Okay. And let's just use a blank expected thing. So now if we make it arguments type char const. Okay. Okay, so let's fix this. Dereference it and get a constant. Dereference it again, get a constant. But now we didn't use we didn't make the header file match. So I'll copy this and commands h make map. All right. Okay. Pointer types. Initialization for incompatible pointer type. xf-printf is not declared. Okay, so we want to. Okay. So we should dereference it and get a const. Dereference it again, get a const. Char const star. Yeah, they seem to map or match excess elements in scalar initializer. Incompatible pointer type. So this is apparently expecting a non-const, I guess. Maybe that's the. I must not understand the right order here. So let me try something else. let's see if I change it, it should work, right? Because I don't expect the variable itself to be constant. Okay, that worked. Oh, I don't understand why this test passed. Make map argv. Must be a problem here. That doesn't make any sense. Make map test is not being run. Omachi mapping. Oh, because I'm returning over here. I'm surprised it didn't give me a warning. Okay. So that gave us seg fault because this array is not defined. So anyway, what was interesting was whether or not excuse me, whether or not we would get a compiler error, and we did not. So let's see. Char const. Okay. Now if I put a const here, it should complain that it's the wrong that it's the identifier itself is constant. Okay, which is what we want. So we don't want a const there. Delete there. I mean, we could put a const there because we're not going to change it, but we don't really, that's not really what we care about. So if I remove, if I add another const, would that convince it that I'm not doing something strange? Duplicate const, okay. So const applies there, const. So how is it exactly an incompatible pointer type? This is an incompatible pointer type. Near initialization for argv. I think maybe the const is not the problem. Yeah, it's not. So I guess I need to do this. Okay. But that was a seg fault. Why is that? Oh, because I'm saying there are two arguments. That's also a seg fault. New sort make map -1. Okay. argv make map argv edit make map.c. v Okay, so I'm not sure what's going on here. Let's printf and see. Hello, this is a message from the future. At this point, I'm going to do about 8 or 10 minutes of xf printf debugging, and I'm going to be making a fool of myself by doing it. And what I should be doing is I should be using a debugger to figure out where the actual seg fault is occurring at. And so I'm going to skip all of the embarrassing stuff and just jump right to the solution. Okay. Well, this is ridiculous. What I did wrong was I specified %s here rather than %d. So I'm going to fix that now. D, because we're printing a number. And it probably did not make a problem before, or it probably doesn't make a problem when it's returning null. right? Because at that point it is, if it's returning null, then it's not going to try and call string lang on it, or xprintf is not going to try and treat it like a string that's going to see its null. And apparently it's smart enough, or it's careful enough to not try and dereference that string. So let's try again. Okay, no segfault. It seems as a code 3. Okay. Exit code 3. All right. So now we can get rid of all of those printfs. Where were we? So I think my problem was that I did not start a debugger right away. Probably I should have just done that, because like 30 seconds after I started the debugger, I saw that it was inside Sterling, and that was inside printf, and then I should have thought, well, why is it calling stringling on a bad string? So let's also change this back to what we had before, because we had something this was actually correct and good. H char const space. Oops. Where is it? Commands dot h, not c. Okay. Okay. And there was an error. Yeah. No new line. Okay, forgot a new line here. All right. Okay, now we can do something interesting. So we are in make map.c. Now, okay, so we're setting ergonomic sort properly. And we need to set the, so, oh, we were testing bad flags, right? So we want to do this again. Bad flag, and call this bad positional argument. SDF. Let's try it again. All right, good. Now, we're setting ergonomic sort to 0 here. And that's good, because we might call make map more than once in this process if it's running in a test. So, excuse me, I'll go get a drink of water. Okay, so I got some water, and I did realize that the reason why I was not getting why I was not catching the seg fault before it happened was because I was using this xfprintf custom function, which like which well, the compiler doesn't actually know that it needs to check this for correctness, and it doesn't know how to. So it doesn't know that like this percent this percent type needs to match whatever is passed to it. And so what I was thinking about doing is looking at the Git source code, because it does stuff like this. So it calls like, it has this like bug utility function, which takes these kind of arguments. So maybe if I looked at like bug fl down here. So we have attribute format printf 34. Have variadic args. So yeah, this is probably something like what I want. Def 1 2. So I'm not sure how to interpret this 3 and 4. I guess it means that the third argument is the format and the fourth argument is where the variadic arguments go. 1, 2, 3. Over here it seems to match that 1, 2. So let me try and just let's try this. Let's see if we can make this sane for the future. util.h, and we're going to do this 2 and 3. Okay, let's make sure that still builds. No. Okay, s printf, vf printf. Oh no, we don't want no return here. Say s printf. You can also do it for this function. And now we can make, let's try that. Senti. Oh wow, so we actually do have some errors here. And we found them with this kind of compiler magic. Kanji distribution.c. So, by the way, do we need to commit anything? Because I think the stuff we're going to fix is in other files. I don't like having to use the interactive patch in Git too often. Just because it's a little annoying. So %d ld long int okay. Type argument 4 has type 1 2 3 4 has type int. Oh yeah, so this needs to be %d. That's right. And is that the only one? I think that might be the only one. Okay, good. So now if we do, we can probably commit this kanji distribution.c and util.h and okay. Fix printf related type errors and add a check. All right. Good. Now, if we were to make the mistake again, I think that this would, oh, we want to go to make map test. This would not, this will give us a compiler error next time. So we did %s here. Yes, it actually gave us an error. Good. That's very good. So we won't waste time again. Now, ergonomic sort. Okay. And edit. So I'm feeling a little unhappy about this global variable. Maybe I should just pass it around because then it's easier to remember to set it to 0. The compiler will make you set it to something or initialize it to something, but here we kind of have to memorize it, and I don't know how I feel about it. I mean, I also don't like passing things around all the time. So, oh, it's not actually something passed to these code finders. Oh, yes, it is. Get kanji codes. Okay. All right, let's keep it for now. So if it is an ergonomic sort, then we need to do a qsort util.h. So this first argument, which I often omit, is something that prefixes every variable name, and I probably don't need that. When I wrote it, I was thinking that I would need it to avoid name conflicts, but the thing is, we're putting it in a do while loop, so that argument is just stupid, and so it's omitted. And because it's a macro, you can just give it an empty string for the argument. So anyway, element is the array, so we're gonna sort the free kanji codes dot L, and the count is free kanji codes dot count, and then the comparator is going to be, so it uses A and B. Yeah, that's probably why I wanted to use the prefix, because it's needed. I mean, that way you can customize what variable you're using to do the comparison. So this comparator is going to be something like a, you know, L A L B, because the A and B are just given to you, assigned for you. Okay, now I guess we'll just say this is a kind of this is ergonomic compare, and no, this is less than, right? Okay, so it needs to evaluate. So if one should appear before the other, it needs to return true. So ergonomic less than free kanji codes dot L A and free kanji codes dot L B. All right. Now we need. No, yeah, this is annoying. Um, let's do it this way. Okay, that's easier to reason about. So, okay, now we need to do implement the ergonomic less than static int ergonomic less than, and then we have oh, what argument of L is probably a struct, right? So we want to pass the first key ch. Oh, it's actually a string itself. So omaji.h. What is shortcode array? Okay, it's a non-null terminated string. So ergonomic less than. So first we car A and const car B. So first we need to check the first element. So the first key ch. Let's see. We want to check the first key index of A, which is going to be char to key index A0, and then first key I of B equals char B0. Okay, so now if these two are not equal, B, by the way, also maybe we should just check if they're -1. IB is -1, then it's a bug. Key in char index map. Maybe we can make an extra function like char to key index or die. Char to key index. In fact, I think we're only using it in an or die kind of scenario outside of the module. Char to key index, static sign char to key index. Yeah, outside of the module, we're always using it in that manner. So you can just call it char to key index or die, maybe. Char to key index or die. Char to key index. See, char to key index or die. I equals char to key index, and if I is -1, then it is a bug. Otherwise, return I. Maybe this should not be signed. Oh, let's just keep it signed. Bug is this over here, same error message. Okay. Or die. Okay. Good. Now, if they're not equal, then return first key I A is less than first key I B. But we do want to modulo it, right? And this can be deleted. So die. Okay. Because this might be a capital letter. So we do want to, oh, and by the way, in the way we sort, if it is just a sort by first character, which hand, row, column. So first character length for only one character kanji code shifted key. Because A and then a character is in the same category as just A alone as a capital letter. Those are all in the same group. So shifted key. Code. So one character kanji code is easiest. All right, just consider that to be the best. So if they're not equal, then return that less than that. But we want to module it, right? Oh, but if they're, yeah, if charted key index, if first key I, B, A is, if first key I, A1 is 0, then it's only going to be one character long. So we'll say return first key I, B, 1 equals 0. If true, then they're the same. Otherwise, but we do need to sort it by the first key first, right? Like if it's in the same category or not. Then we check the length after that. Okay. So kanji key count modulo kanji key count. Okay, that does not fit. So first key I, first key I. Sorry about this. There. Now sent kanji key count. Okay. First key IA. Now if they're not the same, then we check that. Then we can check the length. So change to A. Okay, if A1 is 0, then return B1 equals 0. So these should not ever be the same. Let's make sure that A and B do not compare the same. Str n comp A B2 the length comes last, okay? And so if it's not true, then we say that's a bug. Key codes cannot be equal because we're sorting stuff and we know that each element is going to be unique. So here we say if A is 0, so now we know we have the same first key. So if A is 0, then we want to say now B should not also be 0 because that would mean that they're both equal, right? If B also has a length of 1, then that means they're both going to be the same code, since they can only have a length of 1 if they're a capital letter. So if b1, wait, if or b1 is 0. Here, let's do the terse way of saying it. If not a1 or not b1, then if b1 end, if they're both like that, then that's a bug. Should not happen. This means that we have two codes. Essentially, if there's only for every like first key being the same, for every like one character code prefix, there's only one kind of code that only has one character in it. So we know. So if this were true, in other words, that would mean that a the key index of a, so like 2 lower, or rather unshift, a0 is unshift b0, and the length of a is 1 and length of b is 1, which kind of suggests that you have a key like a and a as well, which is not right. And we know that it's not 2 a's like that because we checked to make sure that they are not equal here. Okay, so I hope that that's convincing to you, but this should not happen. Drink some water. Okay, so now we say it's going to be less than if not a1, right? That would mean that a is the one that only has length 1. So it is less than if a is length 1. Good. So next, what do we care? We check the length. Now we want to see which hand is good. So we now know that the first character is the same, right? So now we want to check if the second character has two, if the two hands are different. So if the two hands are different in A, then that's better than if the two hands are different in B. So we're gonna see if they're alternate. So int alt hands A and alt hands A equals is alt hands A, alt hands B. All right. Static int is alternating hands const-char code, or maybe call it orig. No, yeah, I'll call it orig because that matches the naming convention. So if they're alternate hands, this return orig, or maybe we want to have like a hand function, right? We'll call it hand, the hand of this, of some char c. It's better to give it key s size t, key 1 and s size t, key index 2. We'll call this key index 1, key index 2. Index 1. Okay. Oh, we only need one argument. Key index. Okay, so ki modulo 10 to get the row. Actually, I guess we want to modulo by 5 because basically we have 1, 2, 3, 4, 5. That's left hand, and 6, 7, 8, 9, 0 is the right hand, and then we do the left hand again. Oh, so I guess we want to divide by 5. Equal 5. And equals hand. So maybe we do want is alternating hands, because this formula is just so simple, it's trivial. So we do want is alt hands. Const car. Let me do this. I'm going to start typing constants the way it makes sense. Constant pointers. So now we want to say return a 0 divided by 5. Oh, but we want to do the key index, I guess, right? Dang it. Okay. So we'll say char to key index or die a0 divided by 5 is not equal to char to key index or die a1. Okay. Excuse me. Okay. So it's alt hands A. So if alt hands A is not equal to alt hands B, then you say return alt hands A. If alt hands A is true, that means we want to sort up before B. So we return true for that. Next, we want to check the row. So so now at this point we can ignore the first. We're going to ignore the first character of each code. We don't really care about it anymore. So we're going to get the. Yeah, we want to prefer the third row first, and then I guess the second row next. So I never actually specified this. So ASDF is best. Or I'll do this. Next comes this row, the row right above home. Next comes the bottom row, and then comes the numbers, the number row. Okay. In order to find the row, we're going to have to divide by 10, right? So first key I. Let's do this. Size t. Second key I a. There b. Okay. Second key I a is char to key index or die for a1, and then b. Okay. Now if second key index a is not equal to second key index b, or no, we want the row, right? So so size t, second key row a, second key row b, second key row a equals second key index a divided by 10 to get the row. Oh, over here, we don't just divide by 5 to get the hand. We have to modulo by 2, don't we? Because it alternates. First 5 are left, then next 5 are right, then the next 5 are left, and so on. So we modulo by 2 after we divide by 5. And then, so the row, we can get the row here, b. Okay, now, second key row a is not equal to second key row b. Okay, now how are we going to compare this? Because basically 3 is the best, so the ordering is so if we index it by 0, like if we index the rows by 0, then we say that ASDF is 2 and QWERTY is 1, and the bottom row is row 3, and the top row is row 0. All right. Okay. So, all right, what's the best way to do this? So if not sec key row A or not sec key row B. All right, so we say that the so row 0 is worst. So if either one is row 0, so we already know that the two rows are not equal, right? So we can take that for granted. So here we just say return not sec key row B, because if this is true, if this would suggest if we get to here and if we get to here, then that means one of the two rows is row 0, the worst. So we're going to consider A to be prior to B in the list if B is worse. And so we're saying if B is row 0, then we return true to put A before B. Next is next maybe we can subtract sec key row A minus minus. Now I don't know if I like this. This is just going too far with the terseness. So sec key row. Now we check to see if either one is 1, because neither of them are 0. So now we only have 3 values to check. So if sec key row A is 0 is 1, or sec key row B is 1. Now, actually 3 is the second to worst, right? So we check for 3 next. Row 3 is next worst. Then we return sec key row B is 3. Okay. Now, neither of them are 0 and neither of them are 3. So that must mean that 1 is on row 1 and 1 is on row 2. So we want to say return sec key row B. Now if B is on row 1, then that means A must be on row 2, which means A is the best. A is on home row. So in that case, we return true. Otherwise, then if this is false, then that means B is row 2, which is home row. Okay. Now sort by row of second key, and here we prefer alternating hands, and prefer shorter. Here we say prefer shorter input codes. Okay, so we've done length, alternating hands, and row, and next we're going to do column. We will sort by the column. Sort by column. Okay, and this is a little bit trickier, I guess. So why don't we do this? We can do a uint8 type row or column map. So what we'll do is we're going to divide by. So in order to find the column, there are 10 columns on the keyboard, right? So first we're going to modulo by 10, and that will give us a column index. But then we want to get the column value from the index, right? So if and the two hands have like mirror column values. So on the left hand, we have column Q, W, E, R, T, and Y. And then on the right hand, we have, oh, we don't have Y on that hand. On the right hand, we have Y, U, I, O, and P. And if we look at the column values we agreed on, it looks like this one is, so the column values. Column values, I guess, are here, right? So we'll say A is 0, B is 1, C is 2, D is 3, and E is 4. And we want the lowest column is the best. So what we'll do is we'll say that Q is where? Q is here. It has value of 3, right? And W is here, value of 2. And E is here, value of 1. R is value of 0, right? Yeah, R is 0. And T is value of 4. That's the worst one. And here is just a mirror image. 4, 0, 1, 2, 3. Column value. Okay. Now, I don't like the way these are. There's so much here. There's just so much dead space. So let's fix that. All right. Alt hands A, alt hands B. Okay, sort by column. Now we'll do. Okay. Now the columns could still be the same, right? The columns could still because we know the row is different. So at this point, the column must be different. If we get to here, the row is the same, so the column has got to be different, because that's the only way you can distinguish two characters is by the row and the column. So let's say we have int 8t, or we'll call it int column val A and column val B. And value is like the weight we give to it, which is how good it is. So column val A. I guess now we can just do return. We don't even have to save the column value. Return A1. And then how do we find the column? Modulo 10. And then we find the value of it by passing it to by looking it up in the column value thing, right? Return that is less than column value of B modulo 10. Okay. Sort by column. But we do want to make sure that it's like different, that these are two different columns. Otherwise, it's a bug. So maybe we do want column value A and column value B. Okay, column value A equals. All right. And that is a bug. Columns should be different if row is same. Then here we actually return column val A is less than column val B. Okay, good. So I can't remember anything else that we need to actually code right now. We can make it and see what happens. All right. First key IA. Okay. So we need to rename that. First key I. First key I. IB. Or maybe we can call it fir instead of first, because we did call it this one second, or SEC. First key I. Okay. So fir key I, A, and fir key I, B. Change to A, fir key I. Okay. Qsort. Okay, and util.h. Okay, what did I do wrong here? What's that element? Free kanji codes.l. Assignment to expression with array type. Oh, is this bad because we're assigning an array? Oh, yeah. Okay, Qsort is not going to work as is because of apparently it doesn't like to assign a static array to another static array. Assignment to expression with array type. Yeah. I guess then it should be fine to just redefine Qsort to do a mem copy. Here. Where is that? Because this is doing a swap basically, and I even do a mem copy down here when I set the pivot value. So I don't see why I couldn't just do it for the other stuff. So okay. So here we do B equals A. Just P A. No, P. What is the syntax here? So P is the prefix, and we set it to BL B. Oh, did I do something funny here? Because element is a array. I like index it in the reverse order because in C you know that A and B is the same thing as B A, even though you usually just type the array first. So I kind of did something a bit hacky here. I did that to avoid writing so many parentheses around L, I believe. L P. Okay, so B is set to A here. So we do a mem copy instead. BLBA. Okay. And then we set A to B. Is that right? BA and then A, and then we increment B, and then we do the opposite. So A P B L. Okay. Fortunately, we have some good test coverage, so that should just work. Oh wow. Okay. Good. So maybe we can commit util.h. Well, yeah. We'll commit it when we'll commit it with the rest of the changes, because otherwise it's not clear why that's being done. Well, actually, let's just do it. Util.h support static arrays in array values in Qsort. All right. So make map. Now we can actually try to run make map with this value. Or we can just do it here. New sort make map s. Column should be different if row is the same. Okay. Sort by column. Okay, that doesn't make sense. If row is the same. So I think what I need to do, because bug is like so is not letting me pass any information. So I think that what we'll need to do is like say VA args. Is that what it is? I was just looking this up online a second ago. VA args. Oh no, you dot 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 in the define, like on the left hand side, and then VA args on the right hand side. Okay. Lots of underscores. So 3, okay. So we're gonna do, okay, yeah, we're gonna have to print it out separately. So we'll do xf printf, standard error, and then VA args, right? And then then we print out the rest of the information. Okay, printing out VA args, and then we print out the rest. Oh, but we no longer have bug at. Okay, so bug at there. Specify the location, and then we print out the actual information here. No, it didn't work. Oh, I need a backslash. Okay. / new sort make map s. Okay. The column should be different if row is the same. Now we're not printing a new line though. So man put C. We want to print the new line automatically. F put C, I guess. Put C. Okay. F put C, and I want to know. So we want to call this to print the character. No, F put C here. But what is the return value? F put C return the character nes inside char cast to an int or EOF on error. Okay. So now we do F put C, standard error, and \n. And we're going to add a new utility for printing to xf put C, which will just die if there's an error. So do xf put C, or maybe we want to do uint. What is it? What the type is? Int put C in C. What type do we want to return here? I guess we'll just do int xf put C int C file stream and util.c xf read f put C C stream int res equals that. Now if res is EOF, then we are going to give up xf printf standard error. Of course, we probably can't print any error because we just failed to put a character on the screen. F put C error. That word means error, and then we exit and return res. Or we can just say C change to equals C there. C, okay. Return C. Now let's get an error code just for fun. We'll make it random. '88. All right. Edit util.h and the bug. Okay, so the whole purpose of that was to let us print the actual code. So all right, now we want to print out at most this number of characters, right? So I think we need to, how do we actually do that? I forget. I know I tried to do this before and I got mixed up about how to print with maximum number of characters. So man3 printf %2 %.2 flat characters. Maybe it's dot? No. Precision field width, an optional decimal digit string specifying a minimum field width. The current value has fewer characters in the field width. It will be padded. Instead of a decimal digit, precision, optional precision followed by an optional decimal digit string. If the precision is given as just, then the precision is taken to be 0. If a negative precision is taken as if precision were omitted, this gives the minimum digit to appear. Well, a maximum number of characters to be printed from a string for S and S. Okay, so we want precision. The maximum number of significant digits, the maximum number of characters to be printed. And so precision in the form of a period followed by an optional decimal digit string. Okay. 2.2. Okay. A, B. All right. Bug. Something didn't work. xf put C. Put C. Okay. Cast integer from pointer without a cast. xf put C. What happened? Oh, I mixed up the order of the arguments. Okay. All right. We sort make map S 1, 2, and 1, 1. Well, those columns are different. The column of 2 is different from the column of 1. Oh, because I didn't do the key index, I did the key character. That's why. So if you modulo 2 and 1 by 10, so what is ASCII? So in ASCII, 2 is equal to here. You got 32 and 31. So that means 1 and so modulo by 10 gives you 1 and 2. Well, that doesn't seem right. So then we get 2 and 1 here. Those 2 and 1, that doesn't make sense. They still should not be equal. A, B, A1, B1. What happened? 1, 2, and 1, 1. 2 and 1. Okay. Now we just established that those ASCII values are 31 for 1 and 32 for 2. Let me double check. Decimal. Oh wait, I was looking at hex. Decimal is this one. 49 and 50. So 9 and 0 for the modulo. And so that will give you 3 and 3. Okay. All right. Now, first key index I, second key index. Okay. So key index A, I. Okay. Never actually set these. Charted key index or die. Oh, because I renamed it. Okay. Second key index A. Here. Now we can try again. Okay, good. So now we still have the first character the same. The first character, this codes which share the same first character are still contiguous, it seems. Let me page this to less. And so yeah, it seems like they're all contiguous. All the P's, all the S's, all the G's here, all the K's, L, K is back up there. The rest of the K's are up there. And looks like the capital 1 character code is the first one. And so that looks pretty good to me. Now let's review the criteria we intended to do. So we have row. First, we decide based on whether or not it is alternating hands. Okay. Dun, dun. Okay, so let's go to some arbitrary row. Let's do 8. So F is first. 8F is alternating hands indeed, right, left. Then D is also an alternating hand. 8S is also alternating A. So basically, we should get F, D, S, A, and then G, and then R, E, W, Q. Okay. I'm just making these movements on my keyboard physically to make sure that it's what I expected. V, C, X, and Z. Okay. And then the B is the last one. So 4 is next. So B is considered easier to type than 4, which may not be true. I'm trying to figure it out. It's hard. A lot of this is subjective or very hard to just determine accurately. Okay. And then 8, 1. Yeah. And then 8, 5 is the hardest, I guess. And after that, 8J. Okay, 8J. So now we're no longer alternating hands. So 8J and then 8K. That's pretty hard, but it doesn't really understand the fact that that moving the same finger around makes it really hard to type. Okay. So let me go back. I was losing patience. Let me check again. So 8, then we have 8K, 8L, 8 semicolon. That seems right. And then H, the reach column. U, I, O, P, and Y is the reach column is last. And then that. Okay. That all seems correct. And that is pretty nice. So now we can probably do, let's commit the util changes first, because those are standalone. And yeah, cm util.c and util.h, allow including error, allow including variables or printf-style output in bug. There we go. Okay. Next, make map. So charter key index or die. Okay. Make map. Make map. Maybe we'll fix the type of make map first. We'll do that as a separate check-in or a separate commit. So we'll add commands.h and make map.c. No, don't stage that. Not that. And split that. Include that. And don't include that. All right. Now, maybe we can fix all the commands in one go. So check kanji DB order. Right. So yanked comma. All right, I'm going to try a macro again. So we do Q A. I'll name it A, and we'll say paste it here. Then delete comma, and then end and Q. Okay. Now I'll do it again here. Oh, that didn't work. No. Huh, I must have screwed something up. Okay, never mind. Yanked comma, and paste that, delete comma. Okay, now we edit, check kanji DB order. We want to fix the function itself. And it may just be easier to put this on the system clipboard. And free kanji keys.c. Then change it. Okay, and then print last rank contained, or last rank contained. We can fix the name of this. Delete to L. Last rank contained. Now that's actually a little too ambitious. All right. I'll fix the name in some other commit. Now we'll make last rank. So the tests are not working now. Did you mean last rank contained? Last rank. Oh, need to save this. All right. V passing tag discards const qualifier from pointer type. Last rank contain line 65. Probably gotta fix this. Edit kanji distribution. Okay. Char. Oops. Const. Spacing is a bit confusing here. So, okay. Edit kanji distribution.c. Our V is down here. Okay. Okay. Good. So now we can fix the kanji distribution dot H and C and free kanji keys and check kanji database order and commands dot H. That should fix everything. Okay. Okay, so all the commands and kanji distribution, those are all adjusted. So fix type of argv pointers. All right. Last rank contained. Oh, we didn't actually do this one yet. So yes, we forgot to, I was just interrupted for a second. We forgot to add this into the last commit. So we want to do last rank contained. Or let's do amend last rank contained. Does that work? Fix type of argv pointers. Make map. Okay. And that was the only change in last rank contained, I'm assuming. So now if we look in here, okay. All right. Bug, char to key index or die. Now I wonder if we want to include this char to key index or die in the same commit where we added char to key index, because that would make things a little bit simpler. But maybe not. Maybe not worth it. Okay, so I think the rest of this commit is relatively self-contained. Now we can actually add this. Let's add that as part of the part of the previous commit, where let's see, print map. This is part of generate kanji codes, I believe. Let's make sure. So ff65 is the commit ID, and we want to do git blame on what file was it? Make map ff65 include void get kanji or die. Where's the or die thing? Not yet committed. ff65. Okay, yeah, so right around this line where I added an or die, it was ff65. So we're going to fix up that commit. So it is going to be romaji.c git log. Let's make sure that the last commit to romaji.c was ff65. Yes, it was. Okay. So romaji.star. Yes, we want that. Okay. And -p make map.c, and we don't want this. Split this up, and don't want this. We do want that, and we do want that, and no. Maji dot star. Okay. All right. Now maybe kanji db. Okay. So now we are going to fix up ff65. So git commit fix up equals h5. h5. Okay. Number 5. Okay, now we really have a very simple commit here. Ergonomic sort. Okay. And we do want to add a test for this, which is going to be trivial. Ergonomic sort. Start test. File. Ergonomic sort. Right. Okay. And yes, now we can end test, expect content file. Right. Okay. And I want to make the new test output file so that we have something to diff with. And then we can go ahead and make this a copy here. So copy. All right. Make. All right, good. Okay, now we're going to review what we just accomplished today. So we added the ergonomic sort functionality, and we do this by sorting the keys, sorting the codes according to how easy they are to type. And then we assign the kanji to each key in order of like decreasing kanji rank, where the highest rank means it's more common. We want to input common kanji characters with common key types. And so what we do here is we we have this ergonomic comparator, which first compares based on how long the code is, which means it prefers shift one character key codes above all others. And after that, it prefers alternating. It will prefer alternating hands above non-alternating hands, and then it will sort by the row of the second key. So the home row is the easiest to type, and the top numeric row is the hardest to type, or according to this evaluation. And then it sorts by the column of the keyboard, where the stronger fingers are sorted more easier to type than weaker fingers. And as you know, each column is typed with a certain finger. Next, we actually call ergonomic sort if we have the flag passed. Okay. And we wrote code to parse the arguments or parse the flags. And down here we have these test cases. So I kind of don't like the fact that this is not storing the exit code. So maybe we can fix that. Let's commit this first. So we'll call it implement ergonomic sorting, right? And then we're going to make a fix-up for this commit here, number 7. This is going to just have to do something like this: xf printf error exit code %d. And okay, make. All right, we got a difference here. Exit code 0. All right. Okay. Now we're going to have to add that test or expected test out. Make map test ergonomic sort romaji mapping. Oh, and it's no longer called romaji mapping, is it? Okay. So this should be called default mapping. And that can also be part of the same fix-up. But now we have to rename that thing. Rename the expected test output file. So move expect test output / make map test dot romaji mapping. Make map test dot romaji mapping to expect test out. That's make map test dot c dot default mapping. Okay, now we make. Good. Okay, that looks good, and this is going to be a fix-up of number 7. Okay, now I'll rebase on master interactively, and this will set all the fix-ups in the right position, and then just kind of use them as amend commits. So now we can look back at the make map, the initial kanji code generation logic, and this looks fine. Get kanji codes. Oh, and because the thing we just fixed up, we actually created that test output file. So, and then we renamed it and did a fix up, and so that means there's no rename really, or there's still only one new file. Like we didn't create a file and rename it. We just created a file, renamed it, and then merged the two commits, and so it's still just creating a file. Start test file default mapping. No. Okay. And charter key index or die. So this should probably remain static because I don't think we really need it outside. So let's make that static. Okay. ergonomic.h, and we'll fix up that commit. So this is going to be ergonomic.c. I'll move this charter key index. And I guess we can call this. Let's just keep calling it or die. Fine, ergonomic.c. And we'll call that. I'll fix the type in a second. Chardu key index. Okay. And save the comment here. Chardu key index is static. And here, chardu key index or die is not static. I mean, not signed, and it's not static. I'll keep it signed. Yeah. I feel weird about this return type. Okay. Let's make that. No. Chardu key index. Make map.c. Make map.c. Chardu key index or die. Okay. Or die. Okay. Let's try again. Good. So this should all go back into the that other commit. Make map generate kanji codes. Yeah. That's fix up equals h6. Get rebase. All right. So this should just work, and we should be able to build all the other commits and have it still kind of run the test and still work. Make please declaration xf printf. Did you mean by ef printf? Okay. Make map test. This needs to be fixed. So edit make map test. This needs a util. So let's open 6. And we are going to add util.h. Right. Okay. And then we're going to do a commit, which is a fix up of the current commit. And then we're going to do a rebase. We check out pending and git rebase onto h1. Okay. Then we do 06, and we should be able to make it now. Without errors. Okay. So git rebase I master. Okay. Oh, I shouldn't have done that. I had the wrong thing checked out when I did that. So git reflog is it called? Rebase I. Excuse me. Returning to rebase I start checkout master. Where did I do the rebase? Where did I finish the rebase? Okay, checkout. where should I go at this point? I want to go back to here, I guess. So I can just check out pending. Ergonomic sort of, yeah. Because what I just did was the rebase dash I, which means I must have been right here. So, because commit 7 is this thing, right? So, okay. So check out pending and git rebase I master. Okay, there we go. Now we can check out 6, make sure it builds, and then check out 5, make sure it builds and tests. 4 builds and tests, and 3 builds and tests, and 2 builds and tests. Okay, and 1 should build and test. Okay, and so we finally have now let's see, find make map test dot default mapping. Okay. So no, we want the ergonomic mapping. Ergonomic star there. Okay. So yeah, we now have this actually usable input system, and it's easy to learn more or less. You just have to learn the radicals, and it should be very fast and faster to use than a normal like standard Japanese input system, which I talked about in video 1. And this is just the mapping. So I think for now I might do a little bit of cleanup and something maybe a little bit more like just kind of fun before next. And after that's done, after the cleanup and some like simple stuff is finished, then I'll actually implement this thing, this like visual keyboard. Although that's going to be a few steps later because the keyboard is a little hard. Well, it's not that hard. Maybe I'll just implement it next. And I don't know how long it'll take. So this keyboard that I'm using now is implemented in Perl, but I don't really like using Perl that much, and the rest of the code base is in C, so probably going to re-implement it. And anyway, that's going to be fun, and I'll hope that you'll continue watching then. Thank you.